All right, so you're staring at a maths question and you're thinking, what exactly do they want me to write down to get all the marks? Well, you're in the right place. In this explainer, we're going to tear down a classic GCSE problem about similar shapes and show you how to bag every single point.
Okay, let's get right into it. Here's our problem. We've got these two solids, A and B, and the most important word on the page here is similar. That's the key. So you can see the heights are in a ratio of 2 to 5. We know the volume of the little guy, A, is 12 cubic centimeters. So the mission, find the volume of the big one, B.
Now hold on. Before you start punching numbers into your calculator, we need to get our heads around the big idea here. And that's the connection, the link between a length ratio and a volume ratio. Honestly, once you get this, the whole problem just clicks.
So here's the deal. That 2 to 5 ratio, that's for length. It's one-dimensional, right? Just a straight line. But we're talking about volume, which is three-dimensional, length times width times height. That means we can't just use the 2 to 5 ratio as is. No way. To get from a 1D ratio to a 3D ratio, what do? We have to cube it. So our volume ratio is going to be 2 cubed to 5 cubed. Simple as that.
All right, so how does this actually get you marks? Well, this very first step is your ticket to the first method mark, the M1. It's how you signal to the examiner, hey, I get it. I know the core concept here.
Okay, step 1. Let's find the length scale factor. How do we get from the small shape to the big shape? We look at the heights. We're going from a height of 2 to a height of 5. So the scale factor is just 5 divided by 2, or 2.5. But, and this is the important bit, that's the length scale factor. We need the volume scale factor. And what do? You guessed it. We cube it.
And there it is, that simple little expression, 5/2, all cubed. That is our magic number. That's what's going to let us scale up the volume from A to find the volume of B.
And check this out. This is gold. This is lifted straight from the official mark scheme. It shows you exactly what gets the mark. Just for writing down 5/2 cubed, or showing the ratio 2 cubed to 5 cubed, bam! You've got your first method mark, your M1. You don't even have to calculate it yet.
Okay, 1 mark in the bag. Let's keep going. Now we're going to build on this to get the second method mark. We've got our scale factor, so let's actually use it.
And the logic here is really simple, right? We want to find the volume of the big shape, B. So we just take the volume of the small shape, A, and multiply it by that volume scale factor we just figured out.
All right, let's plug in the numbers. We take the volume we know, which is 12, and we multiply it by our scale factor. That's 5/2 cubed, which is, 5 times 5 times 5, 125, over 2 times 2 times 2, which is 8. So it's 12 times 125 over 8. Now, just setting it up like that right there is what the mark scheme calls a complete method.
And again, let's look at the mark scheme because it tells us everything. It shows you have options for getting that second M1. You could write 12 times 2.5 cubed, or you could write 12 divided by 8, then times 125. See, it doesn't have to look one specific way. As long as your method is complete and correct, you get the mark.
Okay, so we've shown our working. We've got 2 marks out of 3 in the bag. We're on the home stretch. All that's left is to actually do the calculation and get that final answer. This is for the accuracy mark, the A1.
So you punch that into your calculator, 12 times 125, then divide by 8, and you get your final answer, 187.5. And don't forget the units, 187.5 cubic centimeters.
And one last peek at the mark scheme, just to be sure. It shows you what they'll accept. So 187.5 is perfect. But hey, so is the fraction 375/2. They're the same thing. You'll often see OE on a mark scheme. That just means or equivalent. So as long as your answer is the same value, you're good to go for that final A1 mark.
All right, so let's boil this all down. What's the one big takeaway here? If you forget everything else, please remember this.
Here's the golden rule for any question about the volume of similar shapes. If your length scale factor is K, then your volume scale factor is always K cubed. That's it. It's a super powerful rule that works every single time.
And just like that, that's how you nail all 3 marks on a question like this. So that leaves us with one final little thought to chew on. We've handled length, which is 1D, and volume, which is 3D. But what if the question was about surface area? That's a 2-dimensional thing. How do you think the rule would change for that?